Now we are going to make the meshing of this geometry in the Ansys mesher or workbench mesher, and the mesh we are going to use is a very coarse mesh, and just for demonstration purpose this is a good enough mesh. But if you want to make the mesh enablement study, then you should be going for the 3 or 4 maybe more meshes and see how the flow will develop with the time. So anyhow, we start with the workbench. Okay, so here we are, and so this is the already solved case, so I will reset everything inside here. So with the reset, everything will be deleted and we can start with the fresh case. So I will just keep the geometry, but I will be deleting everything else from here. So we have the refresh case. So now double click on the mesh, and this will load the geometry and open the Ansys mesher with the geometry loaded already, which is we created in the design modeler. So you can see in the left bottom corner that it is starting the meshing app, and just wait for it. Okay, so you can see we have the geometry file, and there are the 9 parts. And 9 parts we created for basically for making the hexa meshing. That's why the geometry decomposition was necessary. And the coordinate system is default one. You can use your own. So maybe if for this case, let's say you want to specify the operating conditions on this center point on the top of the geometry, in that case you can define your own system. Okay. And the connections are needed when we are going to make the interfaces between the 2 parts. But in this case, it's a single part, single fluid, single phase, everything, 2 phases, but it's a single volume. And name selections which we created from in the design modeler. So we have the first the bottom boundary, then we have this outside of circular boundary, and the top is a free surface flow, and then we have the orifice which is on the bottom side with the bottom wall. So bottom wall and orifice are on the same surface. Okay, so now we are going to insert the meshing. The first we will insert the method, and so in the geometry selection I will be putting all the parts. So I will right click here and select all and click on apply. The method I'm going to put is the sweep method. Why sweep method? Because the sweep method, when I create the mesh on the one face, this will sweep the mesh across the whole height of the geometry. So it means that this will copy this mesh on all the layers which I make. So if I define the number of layers and number of nodes along the height 30, so on 30 layers this mesh will be copied and then joined together to make it like a full volume. So this is something like you can make the analogy like this is the extrude method in the design modeler or in any CAD software. So it's basically extrude the mesh, the surface mesh, the face mesh throughout the volume. For example, here you can see that we have defined the mesh on the one surface, and when we use the sweep method, so it can go along the any type of the geometry shape. Another case is like this one. So we have the one target face, then there's so the target face on the bottom side, and the source side is on the top. So this is the sweep path. So it can go along the height or the depth of the geometry. And another example is this one. This is in the circular fashion. So source path is this one, and the target is this one. And in between this will create the pure hexa meshing. So maybe on the one surface we have the tetra meshing, but it will create the hexa meshing along the path. So let's continue with our case. So we have the sweep method, and now I will be on the source side. So I will be putting the face meshing, and that face meshing we are applying on the bottom and the orifice. So this mesh will be copied throughout the height. So we are making the map mesh. Map mesh means that we are making the rectangles or the squares. So we are done here. So let's say I generate with the default settings without defining any sizing on the edges. So I just want to see how mesh will look like. So you can see that exactly we have this map meshing on the bottom surface, and this mesh has been swept across the whole height. Okay, now I will be defining the sizing. So, and you can also hide the mesh. You can also make the geometry as the wireframe here. So I'm going to select these edges. So select the edge tool here, and maybe you can try with these sides first. So we have these 12 edges on the bottom surface. So and apply. Okay. And instead of defining the element size, which we do always in the tetra meshing, but for hexa meshing, instead I would be creating the number of divisions. So number of divisions means how many mesh sizes it will be dividing into. So instead of mesh element size, we are giving the sizes it is going to make into these parts. So let's say right now it's a one part only. So we have the two nodes on the two sides and the one element across here. And if I make them, let's say the 9, it means the number of nodes would be the 10, but divisions are 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is for one edge. So for the total 4 edges on the circular path, it will be the 4 into 9, 36 divisions and around 39 or maybe 14 nodes. So you can also make them 9 or 10. It depends on your application. But right now I'm making just a coarse mesh and simply leave it as. So we have defined the mesh for these circular edges. And now I will be defining the mesh for the diagonal edges, first for the inside circle and then for the outside circle. So apply the sizing. So these are geometry parts, and here I will be defining the number of divisions, maybe 5 or 6. Okay, later on I will be defining the bias also, but right now I'm just putting the sizes here. And once I'm done with the sizes, I would be putting the ratio on which it should be growing. So I will take care of the things, many things I will discuss later on this video. Okay, so for this, I'm going to put the number of divisions maybe 9 because it's a very long edges here. Okay, now click on generate and see the mesh. Okay, so this mesh looks fine to me, and I can see the division is properly done, and also the change of the mesh from the one to the second block is also very smooth. So I can leave the mesh over here. Also on the top side, the same mesh is copied, you can see, because of sweep method. The only thing I'm going to make is just make it wireframe is the number of elements on these 4 edges. So I'm going to make the number of divisions 30. And what I make is that I will make it hard. Hard means that otherwise with the soft, what will happen is that maybe the number of divisions may be applied, may not be applied. So it's a software decision to apply the divisions we are giving here, depending on the many conditions for the better quality mesh, for the smoothness. So it will decide itself. So it may apply 30 nodes or may not apply, but with the hard it will apply 30 nodes. Second is that because the distribution right now is a uniform. All divisions have the uniform spacing, but with the soft it can have the more grading towards the bottom and the top wall, because this is a more logical thing. So it can have the more spacing towards the wall. So if you just keep it as it is and soft, it will have some separate division. But if you make it hard and then check the mesh, so this is the result of the hard. So, and if I make it again soft, so I can show you this, what does it mean. So with the soft, the meshing will look like this way. Okay, so now you can see the number of elements here, 57,000, but if you make it as a hard, the number of elements will be reduced. So number of elements are 41 and division here are 20 9. Just make it 29 and see the number of elements. So I want to keep the elements below 30,000 nodes so that the solution can be much faster. So the 40,000 nodes, and now go for these edges here. So number of divisions here are the 10. Edge sizing here is 5. Edge sizing here is 9, and here is. So now let's go for the maybe. Okay, so just keep this mesh and check the mesh quality overall. So this is everything looks fine. So I will just go with this mesh. Okay, the last step is to update the mesh so that this mesh can be translated into the Fluent. So now you can see the message, the mesh translation to Fluent was successful. Now simply save the project and close the mesher. Okay, so the next step would be the computation setup inside the Fluent and running the solution and getting the results for the development of flow, that is the how much time it will take to empty a tank. So next part is about the Fluent.